Hi class, welcome to today's video lesson on 7.1. We're doing operations with radicals today. You guys, this lesson today is totally radical. Like, it is just awesome and just so radical. You're going to love it. I think before we dive into the lesson today, it would be beneficial for us to at least brush over the first 15 squares, because as we reduce radicals, it's helpful to have these numbers memorized, such as the square root of 81 is 9, because 9 times 9 is 81. 14 times 14 is 196, so the square root of 196 is 14. Over the next few days, if you could memorize the first 15 perfect squares, you're much better equipped to solve these questions a lot faster. So we're going to take our first one here as square root 75. Square root 75 is not a perfect square. If you put square root 75 in your calculator and press equals, you get 8.66, so on and so forth. So it's not a perfect square. What we want to do is we want to reduce this radical, because it's easier to work with reduced radicals than with non-reduced radicals. So what we want to do, class, is we want to break this up into two numbers, one of them being a perfect square. So on the previous page, those perfect squares of 4, 9, 16, 25, 36, 49, 64, so on and so forth. What is the biggest perfect square that goes into 75? Well, it is 25 times 3, isn't it? The perfect square is 25, and 25 times 3 is 75. So the square root of 25 is 5. So 5 can come out of the radical. Square root 3, sorry buddy, you have to stay in there. So root 75 is the same answer as 5 root 3. They're the same numerical value. However, 5 root 3 is reduced, where root 75 is not. So I want you to answer as 5 root 3. I'll prove that to you in our calculator that these two are the same numerical value. 5 times the square root of 3 is also 8.6602540338. Look at that, isn't that something? So as you can see, they are the exact same thing. It's easier to work with reduced radicals though. So 80, you are not reduced, we're going to reduce you. It is the same thing as 16 multiplied by 5. Some of you might say, Mr. Berge, but it's the same thing as 4 times 20. You're right, 4 times 20 is 80, and 4 is a perfect square. However, then this 20 is not reduced. You want to pick the highest perfect square that goes into 80. 16 is our highest perfect square, and 16 reduces, the square root of 16 is 4. So the answer is 4 square root 5 for this one. And the number 8 is not a perfect square. However, it breaks up into 4 times 2. And 4 is a perfect square. The square root of 4 is 2. So our answer is 2 root 2. Why don't you guys pause the video and try these 3 on your own and see how you come out. Here we go. On root 32, you should have done 16 times 2, because the square root of 16 is 4. So it's 4 square root 2 is the right answer for this one. 125, hopefully you saw that 25 can go into 125. It's 25 times 5 is root 125. So then it is 5 square root 5. And then root 20, hopefully you broke that up into 4 times 5, because 4 is the perfect square. The square root of 4 is 2. So hopefully you did okay on those 3. On this one, square the following radicals. Let's just quickly do this in our calculator just so that you can see what this looks like. The square root of 7 squared. So the square root of 7, and I'm going to square this. The square root of 7 times the square root of 7, isn't that something? It's 7. So what if I did the square root of 12? What is the square root of 12 times the square root of 12? I bet you can guess what this is. Isn't that something? It's 12. So if you square a radical, all you get left is what's underneath the radical, which is actually called the radicand. This is the radicand. This is the radicand. So when you square a square root, it's kind of like they cancel each other out, and all that's left is 7. In a roundabout way of saying this, root 7 times root 7 is root 49. And what's the square root of 49? 7, of course. So if we have root 237 squared. Well, root 237 times root 237 is 237. So whenever you take a radical and square it, it just ends up with the number that's underneath the radical symbol. Now we get on to something like this. 2 root 5 times itself. 2 square root 5 times 2 square root 5. What we're going to do with this one, we multiply the coefficients by each other. 2 times 2 is 4. And we multiply the radicals by each other. What's root 5 times root 5? Well, root 5 times root 5 is 5. We talked about that in the last problem. So 2 times 2 is 4. Square root 5 times square root 5 is 5. So our answer is 4 times 5, which is 20. Don't believe me? Let's prove this using our calculator. 2 root 5 squared. So we have 2 square root 5 is this number, and if we take that times itself, or if we square it, so that answer squared, look at that, it's 20. Or I suppose I could have done this in one step. If you take 2 square root 5, and then you square it, 2 root 5 times 2 root 5 is the number 20. So let's take a look at this one here. 4 root 3 times 4 root 3. 4 square root 3 times itself. You take coefficient times coefficient, 16. Radical times radical. Root 3 times root 3 is 3. So it's 16 times 3, which is 48. All right, on to the next concept. When you add and subtract radicals, what you do is you basically add their coefficients once the radicals are exactly the same. So you almost kind of treat it like it's a variable. 5x plus 7x is 12x, right? Once the variables are the same, all you do is you add up their coefficients. The same thing is true of radicals. Root 7 and root 7, the radicals are the same, so you could simply add up their coefficients. A negative 10 plus 12 is 2 root 7. 2 square root 7. Let me prove to you that in our calculator just one time. A negative 10 root 7 plus 12 root 7. A negative 10 square root 7 plus 12 square root 7 is this number, 5.2915, so on and so forth. And we said that 2 square root 7 is the exact same thing, did we not? 2 square root 7 is the same thing. Bangarang, 5.2915, blah, 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 blah. So, very cool, right? Fun stuff. So if we take a negative 11 root 21 minus 11 root 21, the radicals are the same. So we can just simply add up their numerators. A negative 22 square root 21. Stink bomb on this one. The radicals are not the same. So what do? We can break down the radical, and maybe after that, then it's the same. Root 6, you're fully reduced. However, root 24, you are not fully reduced. You can break up into 4 times 6. And the square root of 4 is 2. So you have this 2 root 6 is the same thing as root 24, and it's multiplied by a negative 2. This negative 2 right here is times root 24, so this negative 2 is times 2 root 6. Which means you get a negative 4 square root 6. And now you still have this first term. Now it's 2 root 6 minus 4 root 6. Now your radicals are exactly the same, so you could add their coefficients. 2 minus 4 is a negative 2 square root 6. Same thing on this question over here. We do not have the same radical of root 18 and root 2, so we cannot add their coefficients. However, can we break down those radicals? 18, we can break you down. It's 9 times 2, right? And the square root of 9 is 3 square root 2. So I have this root 18 times 3. So I have this root 18, which is the same thing as 3 root 2, times 3. So now when I take 3 times 3 root 2, it is 9 square root 2. And I'm going to add 2 square root 2. So 9 root 2 plus 2 root 2 is 11 root 2. 11 square root 2. All right, and we finished the lesson with rationalizing the denominator. Mathematicians do not like to work with radicals in the denominator. They'd much rather have radicals in the numerator. So if we want to get rid of the radical, a similar thing that we did a few slides ago, if you multiply the bottom by square root 2, what's square root 2 times square root 2? It's 2. Whenever you take a radical and multiply by itself, the radical symbols cancels out, and all you have what's left is underneath the radical. So square root 2 times square root 2 is 2. In a fraction, to make it an equivalent fraction, whatever you do to the denominator, you have to do the same thing to the numerator. So if you multiplied the denominator by square root 2, you had better multiply the numerator by square root 2. So then we have 1 times square root 2, which is square root 2. Class, this answer right here and this right here are the exact same numerical value. They're not any different. But mathematicians like to see this one because the radical is in the numerator. We do not like radicals or irrational numbers in the denominator. That's why this is called rationalize, making the denominator a rational number. I'll prove to you that they are the same numerical value. 1 divided by the square root of 2 and the square root of 2 over 2 are the same number. Here we go. 1 divided by the square root of 2 is this number. And the square root of 2 divided by 2 is the exact same number, 0.70710678112. Crazy, isn't it? Crazy. All right. So what we want to do here is we want to rationalize the denominator. We're going to multiply both top and bottom by the square root of 3, because the square root of 3 times the square root of 3 is 3. And now your denominator is rational. In the numerator, 2 times root 3 is just 2 root 3. So there's our answer for that one. On to the next one. To rationalize the denominator, I multiply the denominator by whatever the radical is. So square root 2 times square root 2 is 2, and 6 times square root 2 is just that. It's 6 root 2. This one, though, we can go a step farther. We can reduce 6 divided by 2 is the same thing as 3. So 3 square root 2 is the answer for this one. Why don't you guys pause the video and try to do this next one on your own. After you tried this one, you multiplied both top and bottom by square root 5, I'm sure. So in the numerator, you got 15 square root 5. In the denominator, root 5 times root 5 is 5. And then you took 15 and you divided it by 5, and you got the number 3 square root 5. 2 left. Here on this one, if I want to reduce or if I want to get a rational denominator, I could just multiply both top and bottom by whatever the radical is. So just multiply it by square root 2. So in the numerator, we get 8 square root 2, because 8 times square root 2 is 8 root 2. In the denominator, we get 3 times the coefficient of 1. 3 times 1 is 3. And root 2 times root 2 is 2. So in the numerator, we have 8 square root 2. In the denominator, we get 3 times 2, which is 6. So then one more step, I can reduce the radical, or sorry, not to reduce the radical, I can reduce the fraction. 8/6 is the same thing as 4/3. So 4 square root 2 divided by 3. Last one for the day. 6 divided by 2 square root 7. Multiply both top and bottom by whatever the radical is, which is square root 7. So in the numerator, we get 6 root 7. In the denominator, you get 2 times root 7 is 7. So we get 6 root 7 in the numerator divided by 14 in the denominator. And again, now one last step. We can reduce this fraction. 6/14 reduces to 3/7. So 3 square root 7 divided by 7. And that is the answer to that one. If you saw right off the bat, we could have reduced 6 and 2 to make 3 over 1. So then it's 3 divided by square root 7, if you saw that right away. Then if you multiply by square root 7, you get 3 root 7 over 7. If you don't see that right away, it's not a big deal. You just kind of go through this work that we did earlier. But if you do see that right away, it could lessen your workload a little bit, but you get the same answer. Let me know if you have any questions about this topic when you get to class tomorrow.